Hello friends, welcome back to your UPSC. So today we will start with another topic of geomorphology, that is weathering, erosion and mass movement. So let's get started. Now first we'll look into weathering. Weathering is simply a process of disintegration of rock in situ. Means there is a rock, it simply disintegrates at its own place. Okay. So this disintegration at its own place is known as weathering. And when this disintegrated particles they are eroded away or they are transported away to another place, this is known as erosion. Okay, so that's the basic difference between weathering and erosion. So weathering is simply a process of disintegration of rock in situ. Okay, now basic characteristics of weathering. So weathering actually decreases the strength of rock. It is quite obvious that the strength of the rock will be decreased because it will be disintegrated. Next is, because it is disintegrated, the permeability and porosity of the rock is increased. Okay, and it helps in formation of new landform. See, when the rock particles are weathered, they are then eroded away, and this leads to the formation of new landform. This we will study in landform formation in erosional surfaces. Okay, now the last one is it increases the area of rock mass. Obviously, like this is the original rock mass. Now because of disintegration, what will happen, its size will expand because of cracks. Okay, so its size has expanded. Okay, now what are the basic controlling factors of disintegration, of weathering? So controlling factors, first is composition and structure of rock. So composition and structure of rock is quite obvious. See, if we have igneous rock, it will be more hard to disintegrate, more harder to disintegrate the igneous rock as compared to sedimentary rock. Why? Because sedimentary rock has layers, sediments, and igneous rock is like a perfect block without having any sort of stratas in it. So it will be disintegrated. It will take much more time to disintegrate than the sedimentary rocks. Next is structure of rock. So in structure of rock, what we'll see that, see, if there is vertical rock structure and there is horizontal rock structure. So the agents will work easily in this one as compared to this one. Why? Because here we have large surface area without any discontinuity. Okay, and here there are various discontinuities, so they will be eroded away faster, and this will take time to get eroded or disintegrate. Sorry, this will take much less time to disintegrate than this one. Okay, next is nature of the ground slope. Nature of ground slope means if we have fall, this type of slope, then weathering will be much easier as compared to this type of slope, and the weathering will be most harder in this type of surface. Okay, so as the angle of slope increases, the weathering rate of weathering of rock increases, and as the angle of slope decreases, the rate of weathering of rock decreases. Next is climatic variation. See, what happens is, we'll see in temperate region their summer are very hot and winters are also quite cool. Okay, so because of this variation in temperature, in summer the rock expands and in winter it contracts. So this contraction and expansion, then again contraction and expansion, this continuous process of contraction and expansion leads to breaking, leads to cracking of rock, and because of which it disintegrate and get weathered. Okay, next is flora effect. see what happens is, this is a rock. So because of flora, first we'll see about physical weathering. Due to the rocks, due to roots of the flora of plants, what happens, the cracks are built in the rocks, because of which the rocks get disintegrated. Next is, sometimes the plants excrete some chemicals, because of which the rocks get disintegrated. Now we will see the agents of weathering. So there are three types of agents of weathering. First is physical and mechanical weathering agent. Second is chemical weathering agent, and last one is biological weathering agent. So physical weathering agents, we will see moisture and water. Water is the important weathering agent. Next is frost. Next is temperature or insolation from the sun. This we'll see, look into this in, we'll look into this in climatology. Okay, insolation. And next is wind. So these were the physical weathering agent. Next is chemical weathering agent, that is oxygen, then is carbon dioxide and hydrogen. And the last one is biological weathering agent. Here we'll see that flora and fauna are biological weathering agent. Okay, now we have seen the agents of weathering. Now we will look into the processes of weathering. So there are basically physical weathering, chemical weathering, then we have biological weathering, okay, then anthropogenic factors, and etc etc. Now we will see physical weathering. So in physical weathering, we will see that temperature was an agent of weathering. So block disintegration due to temperature change. Now what happens is, during morning, the we get more insolation. Okay, we get insolation, because of which the rock expands, and during night the atmosphere get much cooler, because of which the rocks contract. So this contraction and expansion leads to disintegration of rock, and this rock, when it disintegrates, like in blocks, it is known as disintegration. And when this process continuously takes place, okay, now because of this continuous expansion and contraction, small granules are formed, small particles are formed, which is known as granule disintegration due to temperature change. Okay, so in granule disintegration, the coarse grained rocks are formed, okay, because of shattering. Now what is shattering? Shattering is actually, what happens is, this is a heated rock, and suddenly rainfalls occur, and because of rainfall this rocks get cooled down. So like we have seen, we have done experiments. No, we have actually not done this experiment, but actually in our 5th 6th class we have seen that there was an experiment in which the heated bulb was put into cold water, and when this heated bulb was put into cold water, what happened was, this glass of this bulb, due to this bulb was very heated up, okay, because it was on switched on, and because this bulb was heated up, as soon as it was put in contact with this cold water, it shattered. So this is the process of shattering. This is exactly what happens with this rock. Okay. Now we have another term known as spalling. Spalling is repetition of sudden drizzle over highly heated surface. So when there is repetition of this process, spalling occurs. Okay, spalling is also a type of shattering. Next is block disintegration due to frost. This is due to action of water. So this is same like block disintegration due to temperature change, but just in this one is water is the important factor, where in expansion what happens is the water which gets filled in the cracks of the rock in morning it is in liquid form, while in evening or in night it gets solidified or it expands. Okay, so due to its expansion and contraction, the the rock disintegrate. Okay, and this process, when occurred in pre-glacial era, it was known as frost weathering or congley fraction. Now, same like we had granular disintegration due to temperature change, same is the case with frost action. Now we will look into exfoliation. So exfoliation is simply removal of the top layer. Like in onion we have various layers, so removal of the top layer due to temperature and wind is known as exfoliation. Now exfoliation we have term known as flacking. In flacking what happens is differential heating of outer layer and lower shell of the rock mass. So in it what happens, this is the rock mass, this outer layer is heated up very much as compared to lower shells. Okay, so it exfoliates away. Okay, so because when the exfoliation occurs due to differential heating, it is known as flacking. Okay, now uploading. What happens in uploading is there is a lower rock. Over this rock we have superincumbent load. Now as soon as this load is removed, this rock below comes into the contact of outer atmosphere and it disintegrates. Okay, so this disintegration or this process is known as uploading, and due to uploading three types of weatherings occur. First is sheeting. In sheeting what happens is due to uploading cracks and fractures are developed. So as soon as this mass is removed, the superincumbent load is removed, uh, cracks are developed which are parallel. Okay, parallel to the ground surface. Next we have Cambering process. So cambering process is fracturing of brittle sandstone bed along vertical joints. So along vertical joints we have fracturing of sandstone due to expansion. Now what happens is as soon as the load is removed, the rock structure it expands, and due to expansion cracks are formed, and because of which fracturing occurs, and this process is known as cambering. Last one is spalling. In spalling what happens is development of plenty rock fragments in rock due to uploading. So platy rock fragments are formed, or lozenge shaped or irregular forms are formed in rocks because of uploading. Okay, now we have chemical weathering. So in chemical weathering we have first is solution. In solution what happens is dissolution of soluble particle. The best example for this is limestone with water. So as soon as limestone comes in contact with water and carbon dioxide, it dissolves. Okay, it dissolves, and because of which the layer gets weathered away, and the formula for this is CaCO3 plus H2O combining with CO2 gives you CaHCO3, calcium hydrocarbonate. Next is oxidation. Oxidation simply means reaction of atmospheric oxygen to form oxide. Like Fe plus H2O plus O2 gives you Fe2O3 plus H2O. Now next we have carbonation. Carbonation is reaction of carbonate or bicarbonate ion with minerals. Okay, so CaCO3, when it is reacted with carbonate or bicarbonate ion, it forms CaHCO3. So this is a form of carbonation. Next is hydration. Hydration simply means addition of water to the mineral. Same like in this reaction, water is added to the mineral because of which this thing is formed. Now hydrolysis. Hydrolysis, as the word suggests, lysis means breaking down. Breaking down of water molecules. So breaking down of water molecules into hydrogen and OH ion. So this is positive one and this is negative one. So H plus and OH minus ion. So Mg2SiO4 when reacted with water, so because in this process hydrolysis occurs, the water is broken into OH and OH negative and hydrogen molecules. So MgOH and H4SiO4 is formed. Okay. Next is calcination. So calcination is the where metallic ion are incorporated into hydrocarbon molecules. Okay, like this is metallic ion Na, and it is incorporated into hydrocarbon molecule HCO3. So it will form Na2HCO3. Okay. Now next we have biotic weathering. Now we all know that uh, biotic communities like flora and fauna, they are always indulged in destructive work like disintegration and decomposition of rocks. Okay, so flora and fauna, they are involved in weathering. So we have basically three types of weathering in this biotic weathering. First is faunal weathering. Faunal weathering is the burrowing animals, worms, etc. They actually, what they do is they develop a hole or something like that, and because of which the rock is disintegrated. Okay, so this is known as faunal weathering. Next is floral weathering. So floral weathering, it happens, I told you it happens in two ways. First is physical. So physical, in this we have two types of roots of plant. First is taproot. Taproot, we have one basic root, and then we have fibers all over it. Like you can give the example of carrot. Okay. Next is fibrous root. So it is like this, like banyan tree, etc., etc. So these roots, they disintegrate the rock as they develop crack to penetrate inside. Okay, and next is chemical weathering. So in chemical weathering, what happens? It is also known as biochemical weathering. So here, what happens is due to some discharge or cation exchange or calcination, the that rocks or roots of the plant, they excrete some chemicals. So because of these reasons, what happens is cracks are developed in the rock, and they are weathered. Okay, they are disintegrated. And the last one is anthropogenic weathering. So man being a biological agent, it accelerates and decelerates the natural process of weathering. Okay, so for the economic purposes like mining, etc. It breaks down the rock. Okay, so this leads to weathering, and so this is anthropogenic weathering. Now the last one is biochemical weathering. Biochemical weathering actually refers to decomposition and disintegration of rock due to organic material, both floral and faunal material. Okay, so here we can see basically like chemical weathering from floral weathering. Okay, Then faunal weathering, we can in faunal weathering we can see that uh, various bacterias etc. are involved in weathering of the rock structure. They come in biochemical weathering. So chemotropic bacterias and microfungal acids, they actually causes disintegration of rock, and this all comes in biochemical weathering. Now, next is erosion. Erosion, as I told you, is the process of transportation of weathered material. Okay, so it is a process of transportation of weathered material to another place, and this happens with the help of various eroding agents. The eroding agents are water, so this forms fluvial landform, and the erosion type is known as fluvial erosion. Next is ice. Ice, we have glacial erosion. Next, and the landforms are formed glacial landforms. Waves, we have the just a second. So we have coastal landforms and waves, and due to winds we have areolar landforms. Now biological erosion also occurs, and gravity, we can see landslide etc. are due to gravity. Now we have completed erosion, and more discussion on erosion we will do in erosional landforms. Okay, when we will see the landforms, various type of landforms. Now we will look into mass movement. Now, mass movement. Mass movement can simply be defined as gravitational or downslope movement of weathered rock debris. Okay, so this is a rock, and this moves downward due to gravity and or due to slope. So this is known as weathering. This type of movement of weathered rock debris is known as mass movement. Okay. Now, mass movement is basically classified on the basis of movement of rock waste down the slope. So we have like three types of slope. First is vertical slope, second is diagonal slope, and the last one is lateral slope. So vertical slope, we can see here, we will see falls and subsidence. Falls is actually the earth material from very steep slope. Okay, so falls actually occurs when there is earth material and it falls at the very steep slope. Okay, now in falls we will see this is fall. Okay, fall. Now in fall we will see that there are three types of fall. First is rock fall, that is smaller landslide. Okay, so smaller part is uh, moved downwards. Okay, next is debris fall. It involves rapid rate of fall of weathered rock material downslope. Okay, so this was a rock fall, that single rock it fall down. Okay, next is debris. So one after the other, various rock materials, many rocks material, they fall down. Next is earthfall. Earthfall involves downslope movement of finer material than debris fall. Now, now in falls, in earthfall, the it is same like debris fall, just the rock materials are finer than the debris fall in earthfall. Okay, so the fall is of three type. First is rock fall, second is debris fall, and the last one is earth fall. Okay, next we have subsidence. Subsidence is actually, this is a landmass and it subsides downward, and the subsidence is also known as sinking. Now, so this was fall. Now we have subsidence. Subsidence is of two type. The first one is collapse. So collapse actually occurs of roofs of underground caves. So this is an underground cave. So its roof will collapse. Okay. So collapse. And the next is settlement. Now this is collapse of ground surface due to withdrawal of water. Now this is the ground surface and here we have water. So the water is removed. So this area will subside down. Okay, so this is known as settlement. Now next we have topple. Topple is actually rational fall of rock slabs or earth material. So it also comes in vertical fall. Now vertical one is done. So on the basis of movement of rock waste down the slope, we have vertical one, which involves fall, subsidence, and topple. Next is diagonal. Diagonal involves slide, creep, and flow. Slide. So slide is actually characterized by this is a shear plane. Okay, and here what happens is there is a movement above the shear plane, sharp movement. So this is a plane, and here fastly a rock mass it slides down. So this is known as sliding. And sliding is basically of four type. First is slumping. Slumping involves intermittent sliding of rock fragments. Okay, yeah, rock blocks or rock soil downslope. So we have slide. First is slumping. Here what happens is this is the whole structure. This part, this part, it actually slides down. So this part when slides down, here this structure it comes down. Okay, so this structure it comes down. This area is known as slump block. Slump block. Okay, this area. This is the top part which is involved in flow. Here, this one is slump block. Next, we have rock slide. Rock slide, it is also known as rock glide or block glide, and it is basically found in mountainous region where we have large area available. Okay, so the rock falls and rock avalanches occur. Now, third one we have in slide is debris slide. So in this one, a whole rock structure it falls down, and we have seen that in avalanches the whole landmass, it, the cutted landmass, it falls down. And in debris, we have small pebbles, particles like this, they come down. Okay. Now next we have flow. One is slide, next we have flow. So flow is downslope diagonal movement of rock fragment or soil along the sliding plane with enough water. Now flow involves water. Okay. And there are basically soil fluxion, next is debris flow, next is mud flow, then we have earth flow, then rock avalanches. So debris fall involves downslope movement of enormous amount of viscous soil and boulders. So we have flow, it involves debris flow. Debris flow involves viscous soil and boulders mixed together. Okay. Next we have earth flow. This is caused due to excessive water, and here we have finer materials, they downslide. Okay, next we have mud flow. In mud flow, it actually differs from earth flow in the form that we may notice or we may observe that while the latter cannot be noticed because earth flow is not very common. Okay, and the water content is more in mud flow than the earth flow. Okay, this was flow. Now we will see creep. So creep is basically, as the name suggests, it is sliding, but it is very slow and very slow movement, a very slow downslope movement of material. And it is basically of two types. First is soil creep. Soil creep is fine weathered rock debris creep. First we have soil creep. Next we have rock creep. So in soil creep we will see finer materials, finer weathered materials, while in rock creeps we will see a big rock material, unweathered joint blocks, they are slowly downslided. Now the last one is lateral. This was vertical, then we have diagonal, and last one is lateral. Lateral involves spread. So, so in spread, what happens is this is our a rock structure. The Here disintegration occurs, and this part which is disintegrated, it will spread, so the area will increase. Okay, so now this will be the resultant body. And lateral spread are of three types. First is rock spread, second is debris spread, and third is earth spread. Okay, I'm out of focus again. Yeah. So the rock spread, here we can see disintegrated rock block. Here we can see small debris, and here we have finer materials. Now this was the classification on the basis of movement down the slope, movement of rock waste down the slope. Next we have on the basis of speed. So on the basis of speed we have three types, basically three types of mass movement. First is very rapid, which is also known as slide. In slide we can see no water is required. Next is rapid, it involves lot of water, and in rapids we can see flows are involved. So flows we have done here, slides we have done, and slow involves creeps. So all the creeps are involved here, and in here little water is required for the movement of mass. So this requires no water, because of which it actually falls down very rapidly. It requires lot of water, and this one requires very less water. So this was all about mass movement and its classification. and this mass movement is actually involved in landslides. So landslides occur due to mass movement. So this was all about today's class. So that was all for today, guys. I hope you enjoyed the lecture today. So let's meet in our next lecture. Till then, take care and have a nice day.